Okay. Now, one of the important discipline right now, if you see, it may be from the build management or the release management or in DevOps, continuous integration is acting a key role with respect to release engineering. That is, this is an important factor that you need to keep it in mind, that whatever you are doing currently, it's not like you keep developing, you keep doing testing, and you do releasing, because since we have so much of competition in the market right now, so there's a need to keep delivering it as early as possible, right? So in that point of time, what is that we can do is that people brought in agile technologies, all agile methodologies. So agile methodology, basically what it'll try to do is it'll try to break up your complete product into smaller chunks, and you'll be trying to focus on one smaller piece or one component at a given point of time, and you'll be trying to do everything. Okay. Now all these things is being done even from a longer period of time, but still what happens is that the time that everyone has to wait, especially from the user and the QA, in order to complete one round of complete development and testing is going to take a huge time. And that is when the delay comes and all the problems comes with respect to getting things moved forward to the release to the customers. So that is when continuous integration as a concept was brought in. So to understand what is continuous integration, first you should understand a little bit about how the build process works. Okay, so when I say continuous integration, what is continuous integration? And before that, let's just try to quickly say what is the development process. So to put it in simple words, now, when QA is trying to test, how will they test it? So they will test the complete product only, right? They cannot test every time when a developer tries to modify some change with respect to a component on which he's working, right? So when you say testing from the development side, even though they test only few functionality, but they cannot just take one library or one executable and test, isn't it? So they have to test wherein they need the complete product. Only based on that they will be testing a particular area, that is a particular functionality which has to be verified. So if I say that, okay, I want you to check a particular app in the mobile, can you just take the files only for the app and run? Basically you need the complete application, or you need the complete mobile to test. In the same way, if I ask you to test some particular application, where will you see the application? You have to basically install the complete application on your operating system. Only then you can ensure that something is working, right? So like this, no matter what kind of testing QA has to do, first they need the complete product. So in order to get the full product, what is that they have to do is they have to integrate all the changes whatever the developer has done and try to take that change and test. So how will they get all those things? So that is when we will get the build management team into the picture, wherein what they will be doing is they will try to integrate all the code which has been going at a particular point of time, and then they will try to build as a whole product and give it to the QA to test. Now when you try to do this, as I said, every 5 minutes or every 10 minutes someone or the other from the development team would be trying to submit some kind of change. So in that case, will you be doing a full product build every 5 to 10 minutes? Logically it will not be happening, because when you say that you're going to build a complete product, it would take some time. Depending on how complex the product is and what kind of product is, it varies from at least 1 hours to 5 hours, whatever is the product. I mean, how much the files the product contains and what and all you want to do internally. So in that case, literally when QA has to get a complete product for testing, then it will take some amount of time. And at the same point of time, there will be so many changes coming in from the development. So what process they will follow is on a daily basis, they will fix some time. Okay, so you say that every day once every day once or twice they will try to do a full build. When I say full build, it will be a full product build. Okay, and now this is what they'll be taking it and they will be giving it to the QA. Okay, so when they give this to the QA, now what QA will do is they will try to verify this and things are fine. Okay, they'll proceed. Now, say that they do these kind of build once in a day at 6 o'clock in the evening or 7 o'clock in the evening. Now, the question comes, why is that we are doing the build at 6 o'clock or 7 o'clock? It is because when I say that the product full build will take close to 3 to 4 hours or whatever it is. Now, do you want to waste time in doing this during the production hours, or we can do it during the half hours, which means when the developers have completed their day with writing code, at the end of the day, you take all the changes what they have done throughout the day, accumulate or integrate and try to do a build. So since we do it during off hours, we generally call it as nightly builds. Okay, so when a QA is consuming something to test, generally they will be testing it as a full build, or we simply call them as nightly builds since we do it on the night times. Now, so this is the build which the QA will be consuming. So you can have a QA team consuming it on the next day, or since right now if you see people work across the globe. So if say that you are in Bangalore and you're trying to do the development and the QA team is in US like California, Sunnyvale, or even you can have it in any other place. Now in that case, say that at the end of 6 o'clock, 6 p.m. I'll be doing the build, and at 10 p.m. the build would be completed. Correspondingly, if you see, you can take it as a PST or EST time, probably around 9:30 a.m. for PST, that is on a different time zone. When the QA comes, they can start testing it. Okay, now this is the cycle that will be going on internally, but it is not that everything will be smooth sometime, right? Now assume that you are trying to do a build and something fails. Okay, then when we try to find it out, it has been clear that one of the developer has submitted some code which is not compatible as a whole product. So now what is that we have to do? Basically, we have to inform the developer to fix. Now, where is the developer? You are actually finding the bug somewhere at around 12 o'clock or 1 o'clock in the midnight, wherein the developer cannot fix it. So logically, we have to wait until the next day to come, or for him to come to the office and fix. So what will happen? There is a whole wait period of 1 day. And say that, suppose if you have hundreds of changes throughout the day that you have done, literally to find out who is the developer, that itself will take 3 to 4 hours. And that is when we were seeing from the Git how quick you can do some bisect and find out. Okay, say that you do it. So now it will be passed on to the developer. By the time you hand it over to the developer, it will be like 10 or 11 o'clock in the morning his time. He will come, he will take the code, and then he will try to do a verification, and then he will be sending it to reviewing for his team. By the team think everything comes and submits, what if he's submitting it after 6 o'clock? Then even for that day, the fix will not be going. So the second day also, QA will be taking a faulty build, or QA cannot test because the bug still exists. So literally, if you see, even for a small bug, the time has been wasted by QA for at least 1 to 2 days as a minimum. Okay, so in these cases, what is that we can do? Why is that we have to waste such a huge amount of time? Because it doesn't look simple for 1 day, because when you're going for continuous delivery, wherein you're trying to deliver at a rapid fades, then that means that even a couple of hours is going to be a huge problem, because there will be so many developers trying to modify the code and submitting in. Just because one guy's code is breaking the entire product, it doesn't look good that you have to keep all those things in the same way and wait for them to fix. Okay, so to avoid these kind of situations is what continuous integration came into the picture. Okay, so now what do we mean by that's okay, Vimal. I'm sorry, I didn't get you. Who is this Vimal here?
Hi, already?
Let me just go through quickly what is continuous integration. So I was saying that uh, whenever you're working as a team, so when the QA has to do testing, they cannot test it whenever developer is trying to submit some change, because when developer is trying to modify a code, he will be modifying his code only for a particular component, that is only on certain files, and he will be submitting it. So when a QA is trying to test, then they have to test only based on a complete product. So even though the functionality what they'll be testing is very minimal, then what they'll be doing is they have to get the complete product, and only then they can test whatever portion they want to test or whatever functionality they want to test. So in that case, whenever QA is trying to test, it has to be a complete product. So what will happen every 5 minutes, every 10 minutes, or very frequently, when a developer is submitting a change, a QA cannot consume it, right? And also, when you say that you have to build a complete product, then what happens is that it requires some ample amount of time, because when you say as a product, there are so many components that is being put into as a product. So to create a complete product, it will take couple of hours to get the complete product built. So in that case, there is always a time that you have to spend to do it. So generally what in companies people would be doing it as a process, they will be doing this full product build, or we simply call them as nightly builds, at the end of the day, or basically twice a day, depending on how frequently the check-ins happen. So they will be doing this build wherein they will wait for a couple of hours and accumulate all the changes what the developer has done between that time, integrate these changes together as one product, and then try to build the product and then give it to the QA. Okay, so like this, when the QA tries to take the complete build as a product what the build team is giving, now they will try to verify. Okay, so now let's take the simple example. A developer is modifying his code and he submitted at 9 o'clock in the morning. Okay, and now this code has been taken by the build team at 6 o'clock in the evening for doing a full build, or simply for doing a nightly build. Okay, now they try to take this change at 6 o'clock, integrate it with all other changes that went in between morning to evening until 6 o'clock. Now when we start doing a build at 6 o'clock, then we realize that the code is having some problem and the build would be failing, or say that after that when QA is trying to test, something is wrong and they find out that this is the problem. So now when you have to find this and report it to the developer, literally the developer will be fixing it only on the next day, and once again he has to submit it again. We have to verify if something is wrong. Once again it will be found out only at 6 o'clock or 7 o'clock in the evening, for which he will be fixing it only after the third day. So even for a small mistake or small problem, literally QA has to spend 1 to 2 days at the rate wherein they have to wait until the code has been fixed. So this is one of the common problem what the life cycle of the product will be facing. So that is when agile methodologies brought in these kind of concept called continuous integration. So to understand this, this is what I was just giving you an overview of what is nightly build. Okay, now, so since we know what is the problem, what a build team would face, or what a developer is facing, or from a QA team that how much time they have to waste. So how do you resolve this problem? So in order to resolve, continuous integration as a method was introduced. So what is continuous integration all about? So now the question comes is that, okay, why is that we are trying to build completely at the end of the day? Okay, I know that you have to do a full build or a full product build, but does it going to stop us in doing some testing in between which will ensure that things are fine? Okay, now in order to do that testing, how will you do? Again, if you're going to do a full product, you have to spend some time and wait. That is what we are already doing. So instead of that, what continuous integration says that you take a regular interval on every day wherein whenever a developer submits a change, okay, try to take that change and ensure that things are fine. So that means what is that you can do? So say that at a regular interval of 10 minutes, we will be seeing if there is a new change obtained. Okay, now within that 10 minutes, if there is a new change that has been submitted by any user or multiple users, then what we will do is between the 10 minutes range, we will take all the changes that has been gone through. So say that at 10 o'clock we first checked, and then at 10:10 I am checking once again. So when I check at 10:10, between this 10 minutes, two developers have modified some file. So what is that we have to do? We will integrate all these two changes. Okay, so we will take those two changes and then we will go ahead and do a build. And when we are doing a build, we will just try to build only these two components. Okay, so just to ensure that the compatibility is fine. Okay, once that is done, the next thing what we'll do is, why is that we just have to stop here? We will go ahead and run some kind of unit test against these, whatever that we have built. Okay, so in that way, you ensure that the compilation part is working fine with only those two changes what the developers has modified, and at the same time ensure that the test run against those two changes what the developer has submitted. Okay, so now if you want, you can stop until this. If not, since we will be working more on continuous deployment concept, so we can still go ahead and try to create some kind of archive based on what we have built and do a test deployment on a test bed, which means you will be having a separate environment for testing. You can go ahead and do a deployment on that to ensure that the product or the changes is working completely from end to end. Okay, so this way, what are the advantages? If you see, you are not wasting the time for the QA to come and pick it up at the end, which means if a developer is submitting a change at 9 o'clock, we will be doing a build within the next interval of time. So there may be in 9:10 or 9:15 we'll be doing. Okay, so now when we will be taking only the latest change which is modified. That is only his change or any change that has gone through between that interval of 10 and 15 minutes. Okay, next, then you're trying to do a build. So when you're trying to do a build here, you will not be building the complete product. So obviously the time spent on building will be only a couple of minutes depending on what is the complexity of those two changes what it has done, right? So probably it might take another 10 minutes to do the build of only those two changes. Okay, now after that you do the testing and then go ahead and do the deployment if you need. So altogether, if you see, it might not take more than another 15 minutes or maximum 20 minutes. So by 9:30 you can completely say that this change is okay to proceed. Suppose if there is a problem, by 9:30 you can literally indicate to the developer, the exact developer, saying that hey, your code is not working, either it is not compiling or it is compiling, but when we run the unit test it is failing. So this way we can ensure that that the development happens at a faster rate, and also whatever bugs that we can find at an earlier stage itself, we can report it to the QA. So like this, he can go ahead, immediately do the change and submit it once again. Say that he will take 1 hour more to submit the change. Then by 10:30, you will be taking the same change and doing this concept. By another 10:20, you will ensure if things are fine, it is okay. So this way, when the QA comes at the end of the day and they consumes the full build, the problems will not be there. Okay, so this is the concept of continuous integration. So now, to exactly say it a definition or in words properly, what is continuous integration? So continuous integration is the agile methodology, or is a practice where the people keep submitting their change in whatever code line or the branch what they have. So at a very frequent interval of time, we will be trying to pull the data from the SEM tool, whatever you have, and see whether some changes has been submitted. As soon as some changes has been submitted, you will take it and go through a integration wherein you will ensure it has connection with all the other changes and try to do a build. Okay, so when I say build, you can do it manually, or again, you can do it as an automated build. And by doing this process, we will ensure that the bugs or the errors that is going to occur can be catched at an earlier stage, and ensuring that when the QA comes at the later point of time, whatever changes they will be testing should be bug free as much as possible. Okay, so this is the concept of continuous integration. Are you getting it?
Yeah, actually, good.
Yes, sir.
Okay, before I proceed, any questions in, is it clear what is continuous integration now? Okay.
Yeah,
Uh,
actually,
mhm. So unit testing, it depends on what kind of language that you're trying to run. Okay, so we don't have to worry from the unit test, because the development team would be giving us certain files which will do the unit testing. Okay, suppose if it is a JavaScript, they have to write some Java code specifically to unit test, and they will give us the script, or they will be giving us the files, and they will say that these are the steps which has to be executed for running the test. Okay, and if you see, currently we have a lot of tools for doing that test also. So what I'm trying to say here is, the instructions would be given by the development team or the QA team on how we should be doing the unit test, wherein the person who is responsible to ensure this build management has to take care about how this can be automated, and they will be putting it into the continuous integration workflow. Getting that?
yeah, Adams, if you don't mind, can
Yes.
you repeat once more?
Yeah, Adams.
No, when I say unit test, okay, so when we are focusing here majorly as a person, as a DevOps engineer, or as a build engineer who will be maintaining the continuous integration, right? So in this case, our interest and focus is to ensure that this workflow is happening. So literally, we do not care, or I don't say we do not care, it is not our responsibility to keep writing all this unit test code. So depending on what kind of product that you will be using, right, either the development team or the QA team has to give us the steps on what is the unit test we have to do. Okay, so that what we have to do is, we have to just write one small script which will do the unit test, or basically everything will be done with respect to the unit test from the QA team and the development team, and they will just give us the step what we have to include. So we will just take that step and we will add it to the continuous integration. That is what we will be doing, because internally it is the responsibility of the QA and the development team to tell us exactly what steps or what is the unit test you have to do, how you have to do. They will tell us. We just have to incorporate it within our continuous integration process. Getting it?
Yeah.
Okay. So in that perspective, like I said, we'll be focusing mainly on continuous integration and how it is to be done. So this is just a simple workflow, what you're seeing here, wherein if you see, logically the developers would be writing some code which may be developer or someone who's having the permission to modify the code in the product. So once they do the changes and they submit it, we will be polling very frequently into the SEM repository whenever there is a new change obtained. What we'll do is we'll proceed with doing some builds. Okay, so once the build is done, like I said, you can do some test wherein if you see, you can do the test manually by running some scripts, or we have some tools like Sonar which can do some static code analysis also, which will ensure that how much of code has been utilized against what the developers has been really writing it. So like that we can try to do some automated test using some tools like Sonar. Or like I said, if you want to do some deployments, then you can use some application integrated with your continuous integration and get it deployed. And sometimes some companies might want to store whatever the binaries that you have created to some place. So that is when you will use some repository managers like Nexus, which will be storing all your binaries. So like this, the number of plugins or the number of tools that you can attach to your workflow is huge, because every tool can have some kind of plugins which will allow you to talk and do certain step, wherein the main focus of continuous integration is to try to see whether there is a new change obtained by the developer, and as soon as someone submits, then you proceed further with integrating the change, doing a build, and then you proceed with other steps whatever you want, wherein the major focus is on taking the change as soon as a developer submits and doing a build and doing some testing. That is the minimal workflow of continuous integration, wherein you can increase it as much as want based on what extra steps that you want to do. Okay, now when you say continuous integration, there are various ways that you can do continuous integration. That is, either you can do continuous integration manually, wherein say that I can write a script by myself, so that that script will be checking into a repository like Git or Subversion very frequently and see whether if there is a new change obtained, take the change, run some build script, and once that is run some unit test script, and things should be fine after that. So if you want, you can do like that. If not, that is when you have to use some kind of tool which is available in the market which can do everything. If not, what you have to do is you have to spend time in writing all this code by yourself, wherein now if I say suddenly that you have to do some deployment, then I have to write some code for deploying and then I have to include it. Now if you say that you have to do something else after that, like adding up the changes whatever you've done and putting the libraries into some kind of remote repository managers, then again you have to write some code. So like this, the complexity will be getting increased if you're writing the code manually or if you're trying to write some script by yourself. So instead of that, there are so many tools available in the market which will help us to assist. Okay, so going further, so that is what, as I was saying, the actual benefits of continuous integration is that you will be able to detect the bugs as soon as possible. Okay, and separately, if you see, you do not need something to be integrated from the developer code, because on a frequent time we will be taking small changes and we'll be integrating it together and we'll be doing a build. Okay, and as I said, if you want, you can stop the continuous integration only at the testing. If not, you can extend it so that you can have a continuous deployment process also. And top of all these things, what is that we will be doing is that whatever you do, you need to have a history, right? Suddenly if I ask, can you tell me yesterday what is that you built? Because when I say every 10 minutes you are trying to do a build, on a daily basis you will be doing at least 20 to 30 times the build. That means how many times you do a build that you will not be having a count. And if I ask you suddenly, can you tell me in the morning whatever you did, because I see there's some problem, can you just help me to track? Then it will not be possible, because manually if you're doing all those things, then we have to put in log system, ensure everything is fine. So instead of that, if you are going to use some kind of tools which is going to help you in continuous integration, along with it, it is also going to act as a place wherein you can have a complete history of what has been done. That is, who did this, what he did, what and all did you do internally inside it, and what is the output of all those things will be tracked clearly. Okay, and now, as I said, so there are various ways that you can do. That is, either you can write your own script to achieve. If not, go ahead and use some tool available in the market. So if you see in that case, in the market currently, there are only a couple of tools which can help you to do all those things. So in that case, earlier it started with some tool called cruise control, wherein it is not actually a complete user friendly, because again, there was some requirement wherein you have to write some kind of code in an XML format and get the things done. That is when people came with a tool called Hudson. And Hudson was more UI friendly, wherein you can pick what you have to do, what you don't have to do. And then Hudson was more from an enterprise version. That is when they brought in Jenkins, wherein Jenkins and Hudson are both one and the same. So if you're going as a enterprise, then it will be called as Hudson. If it is a open source, then it will be called as Jenkins. And since it is being open source, people started using it, and they are getting so much of advantage because of that. So that is when Jenkins as a tool came into the picture, being in open source, and it got the popularity. So now specifically, if you say why Jenkins, because now if you say there are some other tool like Bamboo which is still being used, but if you try to compare the usage, Jenkins is the one which is quite widely used, because it has so many plugins. Because over a couple of period of years, it has been seen that people started using it very rapidly. Because of it, since it's open source, you can even try to write some plugin from your own and submit it. So that is when there are tons of plugins which is available in Jenkins, using which you can connect to any other tool. Okay, so one thing is, Jenkins is actually a framework. So until now I was just telling as a tool. So if you see, Jenkins is like a framework wherein you choose whatever you want Jenkins to do. Okay, so in that case, it is highly configurable. So it will basically give you some kind of dashboard or stuff, or a framework wherein you will choose, saying that this is what I want to do, this is what I want to do, this is what I want to do, so that you choose what is your process and you inform Jenkins to do. And in order to do all these tasks, there will be some kind of plugin which Jenkins uses. And since it is open source market, you have thousands of plugins that is available. All you have to do is you install that per plugin, whatever that you want to work, and then instruct to Jenkins saying that to work on this plugin, these are the data I am passing it to you. So that is why it is quite popular, because you name any external tool that you want to work using Jenkins, you have a plugin. Okay, and the other advantages is that the build system what you have, it is quite good. That means Jenkins is not going to do anything by itself. It is just going to invoke some other tool to perform some task. So in that specification, it can try to connect to any other tool, which can be any build system tool or any unit test or any deployment tool. Okay, all you have to tell is instruct Jenkins that this is what you have to do. Okay, so in that way, it is quite flexible, that it can do anything that you want to do, wherein you have to instruct to Jenkins that, yes, please do this. For doing this, please use this plugin. Okay, so that is why Jenkins is one of the popularly used tool. Now, this is just from a normal user what we will be talking, but since we will be focusing more on maintaining Jenkins, we need to know a little deeper on the concept of why it will be using. Okay, so now Jenkins also acts as a cron server replacement. Okay, so to clearly give you a picture of this, does everyone understand what is a cron job?
Yes.
Okay, what
Yes,
about
Adam.
okay, Nagesh, Ranji, what about others? You guys understand or know what is a cron job?
Yeah, I know. I have an idea of
Okay.
I don't have any idea about
Uh, what about others?
no, yeah.
Yeah, I don't know about this.
Okay, so since I'm not getting proper answers, let me just give an overview. So, what if, say that I have given you a task and I want you to do it repetitively? What will you do? I'll take back the same mobile example. Okay, don't think why this guy is using the same mobile because few things is easy to show there. So now, say that I want you to do some task again and again. You will put some kind of reminder in your mobile, right? So that it can keep telling you exactly at some point of time what you want to do. So in the same concept, if you have something to do, okay, I'm not saying what you have to do. You can do some test, you can write some maintenance script, or you can do some build, whatever that you want to do, you have to do it very frequently. Okay, now how will you do? So one thing what you can do is every time you want to do some task, you can log into the server manually and keep entering the command or script so that it will run. But if I say that I want you to run some script every 15 minutes, say the same continuous integration build. So every 10 minutes, I want you to do some build. So run the script. So will it be literally possible for us to keep on logging in every 15 minutes and manually run the script? Literally, it will not be possible for us. So in that case, what we can do is if there is some kind of automated system which can schedule the job for us, then it is good. So in that case, in a Linux or a Unix operating system, by default, there is a tool called as cron. Okay, so what this will do is if you give the input to it saying that this is the script or this is the job which I want to run, and if you say at what interval of time you want to run, then it will be executing it automatically. So the same thing, if I say run the script every 10 minutes, then automatically the server will take care of executing it in the background every 10 minutes so that it will be scheduled properly over a time that you have given. And this is how in the production things will be working, because there will be so many things that you have to run it and keep on automating it. Then what you will do is you will put all those entries into this tool called cron in the Linux operating system, and that will take care of executing it everything internally. Now, okay, so now if you understand this much, what is the actual problem by doing this is that it will not just be one task which you want to do on a server, right? Say, take that a developer. A developer has to do some kind of test or whatever upgrades he wants to do. So he might have some kind of scripts to do that. Then on the other side, you will have the build team or whoever is maintaining the builds to ensure that the builds are running. So he would be taking some kind of scripts to do the builds very frequently. Okay, now you go to QA. So QA has to have some kind of script which will ensure that the test suite is completely fine and it is running it automatically. So like this, everyone will have their own jobs which needs to run. And again, being a DevOps engineer or a system administrator, you have to run some kind of maintenance script also. So now if you take one server, it might be running many jobs like this or many scripts like this, which will be scheduled at different point of time. So what will happen internally is that if one of the server goes down, what will happen? So say that you have a server X, and in that server X, if something goes down, what will you do? So say that you have one server X and you have some jobs like job 1, job 2, job 3, something is running. Suppose suddenly if the server is down, then logically what will happen? None of these jobs will be running inside it, right? Then what is that we have to do? So there is a requirement for us that we have to keep on monitoring this, and whenever something goes wrong, then we have to find a server equivalent to the server X. Okay, and then immediately what we do is we have to copy paste all this cron jobs from this place to this place. That is, you have to instruct to the cron tool which is available in this server about all these jobs, so that whenever this server is down, you manually do it. So like this, you will be having hundreds of jobs and hundreds of servers to maintain. So literally it will be not possible for us to keep shifting these kind of jobs from one place to other place. Okay, so that is when we can overcome all these problems by using Jenkins, wherein in Jenkins we have a concept wherein you can group certain servers. So what I can do is we can group some servers like server X and server Y. Now the difference here is, rather than hard coding that you need to run all these jobs in one server, what you can do is you can make sure to say to Jenkins that you assign these jobs to a group of server, wherein you are not tying it up to only one server. So what is the difference here is that now, until now, you put all this cron directly on the server X, so that only when this server is up, this job will get executed at a given point of time. But here, what you're trying to do is you are setting all the jobs in the server called Jenkins, and Jenkins is going to use a group of server to execute. That means now if you say that I want to run it every 10 minutes. Okay, now as soon as you have specified this in the Jenkins, not in the cron, just like the cron which is available in the server, there will be one entry for cron in the Jenkins. So you go there and you tell what is that you want to run and what is the time you want to do it. So when you do that, what will happen is Jenkins at that exact interval of time, it will try to run this. Now, in order to run this, you need a server, right? So for that, what it will do is it will go to this group of server and it will try to pick one server which is available for running this. So in case if one server is down, then logically it will go and use the other server. Okay, so that Jenkins will take care of whatever server is available for completing this task. It will go ahead and run that task on that particular server. So in that case, you don't have to worry about whether this job is not running because this server is down, or this job is not running because this server is down. So Jenkins will take care of distributing the job to a particular server which is available. Okay, so that is why we call Jenkins as an replacement for cron server, which means cron server is nothing but if you are running so many jobs on this server, then we simply call this server as cron server, which is used only for triggering this tasks or jobs. Okay, any questions? Is that clear until now what specifically Jenkins is used for?
Yes,
Yes,
sort
sir.
of.
Yeah, like I had a question.
Yes, please.
Yeah, I had a question. If yeah, if on server one there is job one to be done,
Mm-hmm.
and on server two it is job two,
Mm-hmm.
but I have to do job one, and the server one is like it's down.
Mm-hmm.
So what Jenkins does is it uses the server two to do the job one. Is it so?
Exactly. So when you are grouping the server, okay, so you group only those which are similar. So you don't have to add one separate architecture of server, another separate architecture of server as one group. So suppose say that you want to do some task on only Red Hat servers, then you have 2 to 3 Red Hat servers put together in one group and assign it to Jenkins, so that when you have to do that task, it will just go to only that group and it will pick up. So those kind of facilities are available in Jenkins, wherein you can directly tie it up to one server, or simply you can say use this group, so that automatically anyone among that group, it will be picking it up and it will be working based on that. Getting it?
Yeah. Okay. Thank you. Yeah, I got it. Thank you.
Any other questions? Okay. Now, fine. So now, going little deep into the architecture. So now, until now, I was just giving you an overview of what is continuous integration and why specifically Jenkins, right? Now, to understand how Jenkins works, let me just put you this diagram and work. So now, typically, Jenkins will be working on a client and server architecture. Okay, so when I say client and server architecture, the question comes is that, so do we have a separate installation as a server and a separate installation as client? Logically, no, it is not required, but still it works on a client server architecture. How is that? So whenever you install Jenkins, there is only one install of Jenkins. Okay, so whatever you download, Windows, Linux or Mac, whatever you do, that is pretty much only one installation. This is available. And what is that you have to do? So whenever you install Jenkins, it is going to act as a master. Okay, so when you say Jenkins server, or internally you can simply call it as master server. Okay, now this is the one which is going to act as a server and handle everything. Okay, so here you will be specifying what you have to do, right? What is the job you have to do? So when I say job, you might be interested to run a test build, you might be interested to run some builds, test, or anything that you can do. Okay, so all those things you will be specifying it here as the job. And once you specify all the jobs, then the next thing is at what time you have to run, what is that you have to do. So all those details you will be specifying it here. Okay, so once this is done, the next thing is at that particular point of time, like I said, you have to execute it. So what is that you have to do? Logically, you are not interested to execute it here, but you need to execute each of this job on a particular server. So like I said, one user wants to run some build on Red Hat server, and the other user wants to run it on Windows. And then there is one more user who wants to run his job specifically on Ubuntu. Like this, you'll be having separate servers, right? I can put it like this. Red Hat server, this could be his Windows, and this could be his Ubuntu. Okay, so now what you do is either, like I said, if you want, you can have a group of servers. If not, for understanding, I'm just keeping it simple like this. So now what happens is, when in the Jenkins server or the master server, when you have put up a job, defined it, and you are saying that you have to run it at this point of time, whenever that interval of time matches, what Jenkins will try to do is it will try to connect to this respective server and then pass this job, whatever you have specified here, to this, and it will execute it exactly here. Okay, wherein these servers on which exactly you want to run this job acts as client. Okay, wherein you don't have to exactly install. There are a couple of ways that you can do, wherein you have some client which you have to just run it inside this without installing. You can get it done. So I'll show you when we are trying to set it up in Jenkins how to do it. Okay, so like this, whenever you want to take a job and run, it will try to connect to this particular server and execute, wherein these kind of servers are called as nodes, or we call it as slaves in terms of Jenkins, wherein it is not like completely under the commandment of this master server, but any specific server on which you want to run a task, the master will be connecting to it, and it will be passing on all the instructions what you have given it here over to the server, and there it will be running it. Okay, and once this is done, it will be getting back the data what the server is giving back by completing this job, and then that will be displaying it here. So you have to understand this, because there is no separate two installation. There is only one installation called Jenkins master, and that will take care of doing everything. Okay, so in that case, Jenkins is completely driven by Java. Okay, so pretty much anything that Jenkins runs internally, or it is built up using Java itself, and it runs on Java. So when I said this client, what we'll be doing is internally you will be having a jar file which will be running on this slave. So whenever you run this jar and you just give the instructions to this saying that this is the server and where it is located, then automatically when Jenkins is trying to connect, it will try to reach this node through those jar files which is available on this servers, and it will try to communicate between each other. So if not, if you install Jenkins, there is only one installation and you will call it as master, and that is where you will be specifying all the details inside it. Is that fine?
Yes, yes, Adam.
Okay, so to proceed further, we need to see how Jenkins should be installed. Okay, so like I said, Jenkins, you can install it in Windows or Mac or Linux. There's little difference in what you do. So for the demonstration, I'm going to do it on Windows, but pretty much there is no difference in the usage because Jenkins is just a framework, like I said, and you will be accessing it using your UI, and only on this web page you will be modifying everything. Okay, and then the next thing what you need to know is Jenkins only used for continuous integration, that is build? Because until now I didn't get any question from you guys is how is it going to be used as a DevOps engineer, because you are talking more from build, right? Continuous integration is a build, but is that what a DevOps engineer is going to do? No. The reason I said is because Jenkins acts as a framework. So it is not only limited only to continuous integration. You can define your process or your job, what is that you can do, because it is simply a framework. That is, so if you want it to do a continuous integration, then you specify what are the steps you want to do. If you don't want continuous integration and if you just want to use it as a cron server replacement, that is, no matter what kind of job you do, it will take care. So Jenkins is just going to act as a framework. That's it. Wherein you have to define what is that you have to do, when is that you have to do, and how is that it has to do. Okay, so that is the reason why right now if you see Jenkins is quite so popular, so that it is not only used by developers, it is not only used by QA, or it is not only used by build team or DevOps, it's been used by everyone, because you can automate everything in one single place and you can give an access to everyone so that they can just get their process done in one click of a button. Okay, that is the real power of Jenkins or the usage of Jenkins. So in that case, as I was saying, if you go to the Jenkins page, you will be having downloads. Okay, now if you see on your right hand side, you will have options to download this. So the first thing what you need to remember is you have two kinds of releases here. Okay, the first one is just the release, then the second one is called as long-term support release. So what is the difference between these two? So the first thing what you see release is a beta release, because since it is an open source, so there are some changes that's been done regularly on this and it has been submitted. But beta means there is no proper support for that. So if you're trying to take some latest feature available and trying to work on it, if something breaks, then you will not be getting an immediate fix because this is a beta release. Wherein if you want a proper support from the open source community of Jenkins, then you take this LTS or long-term support release. In general, LTS releases are stable releases. Okay, so whenever you are working on for the production, always please download this LTS. Okay, because beta release is only for those guys who wants to do some changes and modify some behavior. If not, always use this LTS. Okay, so like I said, for the demonstration for now, I've just downloaded this Windows, which is nothing but the exe. So if you just download and double click it, it should be installed. So you don't have to worry about what is the setting that you have to do. But the only thing what you need to do is you have to remember that you should have Java installed. Okay, so at least you should have Java 1.6 or above installed in your system wherever you're working. Okay, so now as soon as you install it, what will happen is, how do you access it? Because internally when you install, there will be some services which will be running. Okay, so in that, what you have to do is, if you just go to localhost :8080 in the server what you're running, then it will bring up Jenkins. So now if you see, Localhost is the host on which we have installed Jenkins. If not in the production, you will be giving the IP address or the name of that server where Jenkins is installed. And 8080 is the port on which Jenkins is running. Because if you see it internally, this is a web application that we are trying to access. So in order to access this, you need a application server running. So when you install this Windows, it puts in a small application, that is a web application or an application server through which you will be accessing this page or port through which you will be accessing Jenkins. So you don't have to worry. Wherein in Unix there are two ways that you can do. So when you click this, you will be getting a var file. Okay, so all you have to do is you will be having some kind of application server running in Unix like Apache or whatever. All you have to do is take that var and go inside the web apps folder of where you have installed the application server and just copy paste it over there. And once you copy paste, if you try to restart the application server, it will automatically read the new file, that is the var file which you have copied, and it will take care about running it. And once again, as the same step, wherever you are running, you just go ahead and give the IP address and say 8080, or for our demonstration we would have been installed in our own PC, so, or laptop, wherein you can just say localhost that points to my current server where I'm working, and then the port 8080. Okay, I'll send in all the instructions, suppose if you're facing problem in Linux, but since for the class you're not be actually going to spend too much of time in installation even in the production, because what is important is there will already be a system that is running, then all you have to do is maintain it and modify. So that is what our major focus is. That is what I'm trying to show it from Windows, but wherein I'll send you the instruction on how to do it on different platforms just in case. Okay. Now, so once you have done the simple installation and when you have this up and running here, so what is that you have to do next? So basically, the first thing we need to do is configure. So for doing the configuration, there are certain things which you have to do one by one. Okay, so the first thing what you need to do is the global configuration. That is what and all values that you have to specify, you have to do it first. And once the global configuration is done, then the second thing what you have to do is you need to tell on what are the servers that you have to connect and do the work, right? So that is what we will call it as nodes or node configuration. So you have to say what and all servers that you are going to use, what is the specification of all those details that you have to say. And third, what you're going to say is creating a job, wherein job is nothing but a group of tasks which you have to perform. So in this job, you will be specifying what is the job, and or simply I can say what is the job and how it has to do, and then when it has to do. So each and every smaller details about that particular task or group of tasks, you will be specifying it in this job. Okay, and these two things are one-time configurations which you will do, wherein going on whenever you have some job, you will be modifying only this. So specifically in your case, when you're going into the production, these things would have been already done. So all you have to do is, based on the requirement, you might be adding some new server as a node, or majority of the time you'll be trying to create some new job to perform some task against some whatever servers that has been added here or whatever nodes that has been added here. Okay, so this is what. Yeah, please go ahead.
Hello? Yeah. See, in real world, where the Jenkins is installed, like most of the times, is it going to be installed like Unix or Linux or different servers?
Actually, I'm not able to hear you completely. Can you speak a little loud?
In most of the times in real world, where the Jenkins, which operating system Jenkins will be installed, like Unix, Linux, or everywhere?
It depends on the user. Suppose if you have a simple use case wherein only a group of people are working within a team, then they might install it on Windows or Linux itself. But if you have many people who are working, then preferably they'll go on to some kind of Unix system like or Linux system, wherein you already have many things running in it, so that it will be easy for them to support. So installation is depending on how much load that Jenkins can take. It is not directly, because internally it is the server which the load can take. Because if I say you have 100 users working on it, now can I allow all the 100 users to work on this Jenkins Windows installation? Pretty much Windows cannot take that much of load. So in that case, what you have to do is you have to choose some server like Linux, wherein that 100 servers or the processes which it will be running inside can be done on the background on Linux. So it is just like what is the use case for you, based on that you will be doing it.
Okay.
Okay, so now in that
But in
case,
most of the companies, do they use on Unix, I suppose?
yeah, it's a mix and match. Suppose if the use is very simple, I mean only limited to a particular group of people, then they will do it on Windows, because when you go with installation on Unix or Linux, then pretty much it will not be comfortable, because if say a developer is trying to do all this thing, and if he's not comfortable with the Unix or Linux system, then he'll prefer on Windows. If not, if it is being maintained by DevOps team or some other system administrator team, wherein they have to support a huge number of processes and products, then they will be doing it on Unix or Linux. Hello,
Okay.
is that fine?
Okay.
Okay. Yeah. So as I was saying, the first thing what we need to do is a configuration. So now when you're trying to configure, configuration is nothing but you have to give in all the details about what and all tools that you're going to work, what and all environment variables that you're going to work. So in that specification, all the settings that you're going to do for this Jenkins server as a global values is what you're going to do it. Because you can set up the configuration in two ways. That is, if you set up all this environment in this global configuration of the master server, then all the nodes, whenever it is trying to connect from the server to this nodes, then it will be passing down all the values. Okay, so that you can set it as global. So if you don't set any specific value per node, then this would be taken by default. If not, you have options wherein you can specify the environment specific to this server. For example, that you want to run on something on Java. So you can say by default Java 1.7 is what you need to run. So you can configure in the global settings saying that Java, which is I'm going to use is Java 1.7. So by default, whenever it is trying to connect to any of the servers, it will be using Java 1.7. But you say that for some particular task, you want to use Java 1.8. So in that case, when you're trying to connect to this some specific server, then in that you can say whenever you are connecting to this server and working, then you use Java 1.8. So like that, you can specify configurations with respect to node, but in order to prevent it, we can set it as a common or a global settings in the global configuration in the master server. Okay, so how do you do it? So by default, when you land into the Jenkins page, this is what you'll be seeing. You will not be seeing anything. So we have to get started by configuring one by one. So the first thing what you need to know is, if you see manage Jenkins, this is the place where all the things has to be configured and managed. Okay, so when you click this, you'll be seeing a whole bunch of options, out of which only a couple of them will be used by us on a regular basis. Okay, so in that case, the very first thing is configure system. So when you click on the configure system, this would give you an option for doing a global configuration with specification to the installation what you have done currently. Okay, so now if you see this, is the page which will help you to configure all those things. And I have just predefined some value so that it will be easy for a demonstration. That is what I've done. So now the first box says the message. So whenever you are trying to log in, right, you can put in some message that will be displayed. And at the same time, this can be used as a banner, because now say that you as an administrator, you are maintaining it and you want to restart the Jenkins for some purpose, or say that you have installed a new plugin and you want Jenkins to recognize it, so you're restarting Jenkins. So in that case, now you will be restarting it and say in couple of minutes. Now what will happen is there might be so many other users who are logged in and you are working on it. Now how will you indicate them is you can just put it as a message here so that anyone who is logging in can read this and he can try to know. So it can either be a welcome message or it can be some kind of banner message to the users, whoever is logging in. Okay, fine. Now going on to the next option, we have something called as number of executors. So when I say number of executors, it is nothing but how many jobs can this particular server take in parallel. Okay, so when I say that, you have this nodes, right? Now when you have created one job and you are trying to say that go to this node and run like this, how many jobs can this node can take by default, or any node that has been specified, how many jobs can a node take? That is what it means, that number of executors. Okay, or simply we can call it as threads. So here we are limiting it to 2. That means on any given node only 2 jobs can be running and can run. Okay, now if the question comes, how do I know how many number of executors or jobs that I can specify? It is dependent on your hardware of the server or the node on which you are running. So take an example, if you are trying to run one script which is going to do a build. Okay, now if it is going to consume say 30% of CPU utilization, then how many jobs can you run? Maximum you can run is 3 jobs, because if you run 3 jobs on the same type onto that whatever server that you're specifying, that is going to use close to 90% of CPU, right? And after that it is going to be a critical problem. So like that, based on your hardware and what is the memory consumption and the utilization of each job, you have to decide on how many executors that you have to. So basically number of executors will be kept minimal, that is 2 to 3. But if you have multi-core processors that you're using on your production environment, then you can increase them based on the hardware configurations of the server. Okay, and the next thing, labels. Okay, labels is the group of servers what I told you, right? I will tell you more in detail when we configure this nodes, but for now you just ignore it here. Okay, then the next thing is usage. So when you say usage, what will happen is how long do you want to use it, or how is that you have to use. So if you see, there are a couple of options for this. That means if you remember, someone was asking the question how it will be picking it up. So if you want, you can specify to Jenkins that use only one server, or you can tie up your job to a particular group wherein based on any server which is available in the group, it will be trying to pick it up. Okay, so there are 2 ways that you can specify, wherein I am just saying the first one because this is a node, or this is your master node is what we need to understand. Now the question comes back is that why do I have to specify all these things in the node? Because all these things has to be specified in the specific servers on which I'm going to connect, right? This is what it has to be done. So for that, what you need to understand is it is not mandatory that you have to configure all these nodes like this. Take a very simple example wherein I want you to run Jenkins to get the system time, or I just want Jenkins to give me what is the current time that you have. Okay, so for that, say that you write some small script or use some command. Now when you use that command, it will give you the time of what is currently there in the system. Now for that, do you literally want to have one separate node or server and work on this? Typically not, right? Then what is that you can do? Then you can run the same job on the master itself. So whenever you have not configured any of the nodes, then by default the Jenkins master itself will act as a node, and all these jobs what you have configured has the capability of running it on the same master server where Jenkins is installed. Okay, so you have to be clear in that. So if you don't specify anything, by default Jenkins will run the job on the same server on which it is installed. Okay, so in that case, now this is why the option would be using. So in those case, when you are creating a job but you have not specified where to run this job, so even in those case where you have configured the node and you have informed to Jenkins, but if you have not instructed to Jenkins that, say for this example, I have not instructed this job to run on some particular server, so in that case what Jenkins will do is by default it will run this job on the same server on which the master is installed and running. Okay, so for that purpose we have to use this usage. That is, I'm going to say use this as much as possible. So I don't want to restrict anything. So by default, if any job doesn't have a specific node attached to it, and then it means go ahead and use the master Jenkins itself and run as much as possible. And that is why you keep this option. Okay, now the next thing, quiet period. So quiet period is something wherein, say that you are trying to execute some task, right? So now I have said that you have to do this job something on this server or whatever server. Now say that you are trying to connect to the server and you are trying to perform some operation. But what will happen, since you are trying to connect from one server where the master is installed to other server on which you have to run the jobs, there might be some network glitches. So in that case, what will happen, whatever step that you are trying to execute will be failing. Okay, so then what will happen, the job itself is failing is what Jenkins will tell. But sometimes we know that it might be a network issue which can be resolved quickly. Like one quick example, like what you said, the audio was disconnected but within a couple of seconds it got connected. So in the same way, now what you can do is you can set a quiet period, which means before executing a particular task we can instruct to Jenkins to wait for some seconds, so that you can ensure that, okay, something, if a connection is getting disconnected or if there are some network issues, it can wait until that second and then try to proceed with doing the exact steps what you have specified in the job. Okay, so whatever you specify here is the number of seconds that Jenkins will put that job in hold before executing it. So in the same turn, now since we are focusing more on continuous integration, wherein if you're seeing, you would have to frequently connect to some kind of SCM tool and perform some kind of operation. So in that case, again, if something is not working or it is not able to connect to the SCM tool, you can specify how many times it should reconnect and try. So if you say 2 times, then if your connection is not happening between Jenkins and whatever SCM tool that you have specified, like Git or Subversion, then it will try to reconnect once or twice based on the numbers that you have specified here. Okay, fine. Now this is the default global definition that you will be giving it for the node. But going to the next option, we have different tasks to be done. So for each of the tasks you have to done, correspondingly there are some kind of environment variables which you have to set, right? So in that case, how will those will be passed to the node? So like I said, either you can set all this thing as a global value, or you can set all these things individually in each of the node. So one example was I was talking about Java. So in the same case, you have to first think about what and all are the tasks which you are going to do in each of the job, and correspondingly what and all environment variables that you need. Okay, for example, if you are going to work on ant as a build system, then there is a need to specify a ant home environment variable, giving in the details of where is the ant installed. And just like I said, Java has to be installed by default, and in your job, if you are using some kind of tools which requires Java, then you have to specify the Java home here. So like that, you can add as many environment variables that you want to put it up and define all those things. Okay, so you keep on adding some name specific to what environment variable it has to create, and correspondingly, what is the value associated with that environment variable, what you're creating. Okay, now this value will be taken again as a global value. Okay, now once it is done, by default, if you see, it gives you some options like this. It gives you for JDK, it gives you for Ant, Maven, everything. Now here, as I said, Jenkins needs to know what is the Java version that it is installed, right? So here, specific to the JDK, JDK is nothing but Java Development Kit. Okay, so now if you know that Java is being maintained or taken over by Oracle, and Oracle is the one who provides the Java. So now in that case, there are different things which you need to work on Java, because for us as a normal operation users, we just need the Java executable to compile a program or run a program. But when you take as a developer, there are a couple of other things which we need, like you need to have a Java runtime environment, or you need to have a Java virtual machine internally with some things which the developer wants to do. So in those case, the development kit is a suite which will be containing all these things together as one single product. Okay, so JDK is one such wherein you will have all the requirements for a developer in order to assist him in this development activity. So we are going to take the same so that we will have everything in our system also, so that if you're trying to compile or do some tests, you can have all the features of Java which is available. So in that case, we will just define some local JDK or some name which represents what installation Java that we have. So literally, if you see, it is the same thing what I'm going to specify, but by adding it here, going on, whenever you work on this master installation, it is going to take this particular installation of Java. Okay, and as I said, you can configure multiple values. So if you want, you can specify 1.7 and 1.8, and later when you are defining the job, you can say that for this job I need 1.8 specifically. If not, I will defaultly go with whatever you have kept here. Okay, so like that you can put an option here, but remember, whenever you're defining it, you have to remove this install automatically, because what it will be doing is it will be trying to upgrade it every time, because even without asking you, it will go ahead and install if there is any upgrades. So for that purpose, you have to remove this. By default, it will be enabled, plus ensure that you remove it and give these two values. Okay, fine. And once that much is done, now the next thing, if you see, there will be certain options for the tools. So by default, all these things are tools which has been pre-built in your Jenkins. So when you install Jenkins, all these configurations will come, wherein depending on what is that you are going to use in your jobs, you have to specify. Suppose, say that you are going to work on Ant, then you come here and give the details about where the Ant is installed, so that whatever that you give here is what you will be using inside job, wherein try to understand the previous one, whatever you gave, these are environment variables, wherein here whatever specification individually that you're doing are the executables which will be used by the job when it is running. So if you have multiple instances of the executables, then you give multiple values here, so that when you are writing a job, it will ask you, okay, now you are instructing to Jenkins saying that execute Java or execute Ant. Now it will go and ask you that what version of Ant you want to execute or what version of Java. So in that case, whatever you have configured here, this will be showed there so that you can have an option of whatever you have specified. You can choose one among them from the job. Okay, so like this, you will be having specification for each one of them, wherein majority of the time we will be either using Ant or Maven. So we will be specifying more about where Maven is installed, and this is just a dummy name to identify this installation of Maven. Okay, so like this, whatever tools that you are interested to work on, you will be installing the plugin and correspondingly this option will come. Okay, so like that, by default, if you see, Ant and Maven will be present in the page when you install, but assume that you have to work on Git. Okay, but Git will not be available by default. So what you have to do is, there is something called as plugin, which I said. So you have to install that plugin, and only when you install the plugin, this options of whatever you're seeing will come. If not, this will not be there. You'll be directly seeing only Ant and Maven. So in the next classes, I will tell you how to install those plugins. So for now, you just try to go through this and the recordings, whatever we are given. So you just try to reproduce the same thing. So once you have configured all these things, pretty much what you have to do is you have to come at the last step. So first thing is you have set the global values. Second thing, you have set it the environment variables, and then third is what are the build tools that you want to configure, that is Ant, Maven, that you have specified. And the fourth thing is specific to SEM tools, because Jenkins is mainly used for continuous integration. We need to see that how do we connect from Jenkins to any kind of SEM tool like Git or Subversion or Perforce. So by default, Jenkins will be giving some options for CVS and Subversion. Okay, so if you are working on this, you can specify. If not, in our class, majority of the time you'll be using Git. So what we will be going is, we should have installed the Git plugin so that it will try to show it here. So in your case, if you try to install Jenkins and you're trying to do it freshly, you will not be getting this option. Remember, for that you have to install the Git plugin. That I'll show you later. So once you configure the details about where is the server, how do you connect it, or what is the username, password, that if you want, you can specify it. So once this much is done, you can just say apply and save. Okay, so remember what and all things you have to do. Go to manage plugins, and the first thing is configure system, in which you have to specify the four types of configuration, wherein the first thing you will specify is the global master settings, and then you will specify the environment variables, and then you will be specifying the information on build tools, and then finally you will be configuring or giving the information of SEM tools. So these are the four things which you'll be doing it, and it will be just one time. So after that, if you see, it will be more on these two only. Okay, is there any doubts or questions until now?